Hi, my name is John Mumba, chemistry tutor at Excellence Tutorials. Welcome to today's video on how to come up with empirical and molecular formulas. Now, when you're looking at empirical formulas, it is always important for you to know the percentage composition of the given components of that particular compound. By components, I mean the elements found in that compound. So we have a good example here that is going to demonstrate to you on how this empirical and molecular formulas can be calculated. So you have to follow through the procedure on how this is done. So let's look at this question. It's actually an easy one. It's not hard. So the question says malic acid is an organic compound composed of 41.39% carbon, 3.47% hydrogen, and the rest is oxygen. Now, if 0.129 mole of malic acid has a mass of 15.0 grams, what is the empirical and molecular formula of malic acid? So we have a table here. This table is where everything is going to be done. We'll just do everything from here. So let's look at it. So we have carbon, C is standing for carbon here, H for hydrogen, and O is for oxygen. Now, the first aspect we're going to look at is the mass aspect. So let's look at the mass aspect. So what is the mass of carbon? What mass of hydrogen is there? What mass of oxygen is there? I'm sure you heard me in the introductory message that whenever you're writing or coming up with the empirical formula or molecular formula, it is important to know the percentage by mass composition. So what we do here is we're going to turn the percentages that are given in the question. Those are the ones that are going to become masses, because we are going to be using the principle of percentage by mass composition. So we assume that these are masses, so 41.39% carbon becomes 41.39 grams of carbon. Then 3.47% hydrogen becomes 3.47 grams hydrogen. And the rest is oxygen. So, Newton, may you help me calculate the rest? So 200 minus 41.39, then minus 3.47.
It gives 55.14 grams.
55.14 grams oxygen.
Yes.
Thank you very much. So those are the masses. Then from these masses, so these are not the actual masses of carbon, hydrogen, and oxygen. These are masses collected according to the percentage composition. Now let's look at the next aspect. So the next aspect is the mole aspect. So if this is the percentage composition of carbon, then how many moles of carbon are in malic acid? So we know that moles, the number of moles is given by what? Mass over molar mass. So the mass here is the same 41.39 grams over the molar mass of carbon. This one you check on the periodic table is 12.01 grams per mole. Grams per mole. And that will be what?
This gives us 3.445.
5. I want to 4 decimal places.
Okay. 3.44562.
4456.
Yes.
Then because you say 62, so we can take it at 3.4456. Very good. Then for hydrogen, the number of moles would be the mass, which is 3.47 grams over 1.01 grams per mole. And that is what?
3.456.
356. Good. And now for oxygen, we are also going to calculate the number of moles. This will be 5.14 grams grams per mole. Anyone else to try? Not Newton. That would be what?
3.446
3.4425,
so it can be 23. 4463.
63. Thank you so much. Thank you so much. I feel good that everyone is participating. Very good. So let's go to the next aspect. Now, this is the last aspect in case there is nothing more. So what I mean is, by these two boxes, we have to fill them all, but it's not always mandatory. Maybe this other one will go. I will show you what I mean. So the next one is the mole ratio. So the mole ratio here. Mole ratio. So in the mole ratio, we are going to be dividing all these number of moles by the least number of moles. So here we have the first one is 3.4456, 3.4356, and 3.4463. So that means 3.4356 is the least number of moles. So we divide all this by 3.4356. So we get 3.4456 over 3.4356. What does that give us?
It gives us 1.00.
1.00 something. So we can say this is approximately what? 1. Are we okay with that?
Yes.
Very good. So then the next one will be 3.4356 over the smallest 3.4356. This is just 1. And the last one is 3.4463 over 3.4356. And this will be also approximately 1. Now that all these numbers here are 1, that is, we don't have decimal places, we don't have decimal numbers, then there's no need of the last part. So we're just going to get the empirical formula from those that we've done. So this part here, I'll just rub it. Okay, so now, what would be the empirical formula? So we just say the empirical formula in this case is going to be carbon. So we have 1, so because it's 1, there's no need to write. Hydrogen, also there are 1. Oxygen, again 1, so there's no need to write. So this is the empirical formula. So I'm sure you've seen it's not that hard. Very simple. Now, from here on the empirical formula, we're not done with the question. The question says, what is the empirical formula and molecular formula of moleic acid? So since we are done with the empirical formula, we go to the molecular formula. So how do we get the molecular formula? So for us to get the molecular formula, we need to know the total mass of 1 mole of this compound. 1 mole of this compound, what is its mass? Now, we have been given here that 0.129 mole of moleic acid has a mass of 15.0 grams. So this is not all, just 0.129 mole of it is that one. But what of 1 mole? How much is it? Because that's what we're interested in. So if it's 0.129 mole gives us 15 grams, 15.0 grams, then 1 mole will be what? We don't know. So we cross multiply x times that. This will give us 0.129 mole. X is equal to 15 times 1 mole. So 15.0 grams more. So we divide this by 0.129 more. Also here by 0.129 more. So that is what? That means X is going to be what?
116.29.
116.29
grams.
Thank you so much. So that means one mole of the whole of this compound, so-called moleic acid, has 116.29 grams. So then, what would be the molecular formula? So for us to calculate the molecular formula, we need to know the mole ratio. So the mole ratio is R is equal to molecular formula mass over empirical formula mass. And here the molecular formula mass for 1 mole is 116.29 grams over the empirical formula mass. So the empirical formula mass is calculated by finding the molar mass, or rather the molecular formula mass of this. So the molar mass of this is what? For the empirical formula. So carbon here, we know that it is 12.01, that's the mass of carbon. Hydrogen 1.01, oxygen 16.00. So if we add 12.01 plus 1.01 and 16.00, what do we get?
29.02.
So this gives us 29.02. So that is what we write here, 29.02. So then 116.29 divided by 29.02 grams will be what?
4.
It is 4 point what?
It's 4.00.
4.000, so okay, thank you. That means it's really 4. Okay, that's not what I was not really getting to say it's just 4, because I had some ideas that this could be more than just 4. Okay, so it's approximately 4, or we can just say it's equal to 4, there's no problem. So that is the mole ratio. So now, when you get the mole ratio, what you do is that from the empirical formula, we have seen the empirical formula is CHO. Then what we do is you bring in what? R. So this is the ratio. And that will be CHO, and our ratio is 4. Which means that when you do that calculation, here it's showing that we need 4 atoms of carbon. So you say C4, then H4O4. So this is the molecular formula of moleic acid. So just in case here on hydrogen we had 2, we are going to multiply 2 times 4, which means it was going to be 8 here, and then the rest becomes 4. So you just have to multiply everything that is here, the subscripts of all these atoms, or rather elements. So this is the molecular formula. So that's how you get the molecular formula and the empirical formula. I don't know, but I'm so sure that you've gotten this idea, you've really understood how you can calculate the empirical and molecular formula of compounds. So may you come back next time and watch our tutorial videos. Excellence Tutorials is all about understanding physics, chemistry, and mathematics. And we're there to help you and those others who are not there already liking or rather watching our videos. So you can also help us by sharing to the next person. Thank you and have a great day.